Alright, I put together a circuit that basically displays, shows a, you could use either voltage or frequency to control a power output. So here's my fan, it's off. I got a little light bulb here. This is my sine wave generator. We're going to be using it from between 0 to 35 kilohertz today. Got my two power supplies, one's for the light, one's for the fan. And kill switch, always useful. And a little transistor here we're going to use. And this is a 1-to-1 transformer. This is my power output transistor, and it is awesome. I've been testing it under probably max of 150 milliamps, and it got a bit slightly warm is all. Even without the fan, I repositioned it so the fan, when it's on, is in its path, so it'll cool it, but it's really not necessary. So anyways, you can see we got about 5 volts coming out of our sine generator, and what I'm gonna do is turn up the voltage, and as you can see, as I turn up the voltage, the light starts to go on, and you see how it blinked off right there. It's kind of fighting with the fan for the current, and you can see now we're at 16 volts on our sine wave generator, and we are in business. We're running pretty good here. Right now we're running at 35 kilohertz, and as you can see, we're increasing the voltage. That's 19, now 20 volts. That's the maximum output for the wave generator. Now, the sine wave generator is not going to produce the current. What's going to produce the current is these two power supplies. So now what I'm going to do is actually, as you can see on the scope, we have the waveform that the generator is outputting. We're going to change the frequency here. You can see how you can actually hear the fan get lower in its speed. Now we're at 10 kilohertz, still at 20 volts, and you can hear now our current is up to 140 milliamps. So actually we're going lower, we're drawing more current. Now it's at 150. Okay, so we're going slower on the fan, and we're still at 20 volts, and that's 5 kilohertz. Now we're at 160 milliamps. Now, curious, watch what happens here. At 1 kilohertz, all of a sudden, we dropped 110 milliamps, and it's at the fastest speed it can go. And that's at 600 hertz. That's at 200 hertz. And then it drops off. So, just 1 second. So this is us back at 35 kilohertz and 20. Now, at 35 kilohertz, we're drawing 120 milliamps, which is reasonable. Just found those findings to be kind of interesting, that it would slow down significantly, and then all of a sudden, when we reach about 1 kilohertz, it starts to ramp up. So, as you can see, also, as you expect, when we lower the voltage, the current goes down 16 milliamps, and obviously the fan speed lowers 9 volts, 30 milliamps. So that's a lot more linear. As you can see, also the light is dimming accordingly. But when we use the frequency to control it, it's not such a linear curve. So anyways, that's the circuit. I hope you enjoyed it, and see you next time.